Unit 2.6, we do practice. The following pertains to the phosphate ion PO4 3-. Draw the resonance structures for the ion, and then what is the bond order between phosphorus and H oxygen atom in the ion? So, as with any Lewis dot structure, we first need to start by finding our total number of valence electrons. So my phosphorus has 5 valence electrons, plus my oxygens, which each have 6 valence electrons times 4. And then we're going to add 3 more electrons because we have a 3- charge. So we're going to get a total of 32 valence electrons for this phosphate ion. Then we're going to stick our phosphorus in the center because it's the only phosphorus and I have 4 oxygens, so it kind of makes sense. But it's also the least electronegative element because phosphorus is less electronegative than oxygen. So I'm going to stick my phosphate in the center and connect all of my oxygens with single bonds. And now I'm going to do my quick check to make sure that I've placed all of my electrons and that everything has fulfilled its octet rule before I move on. So when we count, we've placed all 32 valence electrons, and our oxygens and our phosphorus all have their octet fulfilled. They all have 8 valence electrons, so it feels like this is good, that this is correct. But as we've recently learned, the only way to be sure that this is the correct or the most likely Lewis diagram or Lewis dot structure is to apply our formal charges. So let's get our formal charges together for our phosphorus and oxygen to make sure that this is in fact the correct structure. And the other reason we want to check this is because phosphorus is in that third period, so it can take an expanded octet if it needs to. So we definitely do want to check to see if phosphorus might be taking on an expanded octet here. So for phosphorus, our formal charge is going to be equal to our number of valence electrons minus the assigned electrons. And our assigned electrons are going to be our lone electrons, which we don't have any on our phosphorus, plus our bonds attached to that atom. So phosphorus has no lone electrons, but it does have 4 bonds. So 5 minus 4 is going to give us a +1. And for our oxygen, our valence electrons are 6. So 6 valence electrons minus our assigned electrons. So assigned electrons, our oxygen has 1, 2, 3, 4, 5, 6 lone electrons plus 1 bond. So 6 minus 7 equals -1. So let's put these formal charges onto my atoms and see what we have. So my oxygens all have a -1 and my phosphorus has the +1. Well, this does work out. My -4 plus 1 does equal a 3-, which is the overall charge of my phosphate ion, but none of my formal charges are 0, and I want my formal charges to be as close to 0 as possible. So this is probably not the best way to do it. So let's take a look at our phosphorus and see if we can get our formal charge to be 0 on our phosphorus. And in order to do that, if we have, so for phosphorus, if my formal charge is 0, that means I've got 5 valence electrons minus something, some number of bonds, plus 0, right? Because I have no lone electrons on my phosphorus. So it all comes down to my bonds. So in order for my formal charge on phosphorus to be 0, I have to have 5 bonds. So let's give that a try. Let's actually take away a lone pair from one of my oxygens and let's make a double bond so that I have 5 bonds on phosphorus and then single bonds on the rest of my oxygens, and see if that will lower my formal charges, get me some 0 formal charges while still maintaining that overall 3- charge. So now if I recalculate this, my formal charge for phosphorus is going to be 5 minus 5 plus 0, our 5 bonds plus our 0 lone electrons. And my other oxygens are going to still be -1 and -1 because I didn't change those. But now for my double bonded oxygen, I still have 6 valence electrons minus my dots, my lone electrons, so 1, 2, 3, 4, now lone electrons, plus my bonds, which is 2. So 6 minus 6 equals 0. So now I've gotten my formal charges on everything closer to 0. So my phosphorus has a formal charge of 0, my oxygen has a formal charge of 0, and the only ones that have formal charges are the ones that need formal charges, so that overall, my overall formal charge on this is 3 minus because of those 3 oxygens, and that's what I need to match the overall charge on this polyatomic ion. So now that we know that this is the more likely structure, we can finish it up because we're not quite done. Remember, it's an ion, so we have to bracket it and put the charge on the outside. And because now we have a combination of a single and a double bond, we need to draw our resonance structures. So there we have it for part A, our phosphate ion with its 4 resonance structures. So now that we have our Lewis dot structure, we can answer part B that asks, what is the bond order between phosphorus and each oxygen atom in the ion? So remember, to find our bond order, what we have to do is we have to take our total number of bonds. So we've got 5 bonds divided by our number of bonding sites. And in this case, we have 4 bonding sites. So 5 bonds divided by 4 bonding sites, and we get 1.25 bonds. Remember, when we have resonance, we actually have all of our resonance structures existing simultaneously. So we're going to have these weird number of bonds. It's going to be 1 point something, 1.5 bonds, 1 1/3 bonds, or in this case, 1 1/4 bonds. So between all of our oxygens and our phosphorus, we're going to have 1.25 or 1 1/4 bonds, and that's going to be our bond order for the phosphate ion.